Welcome to my YouTube channel. So today I will solve some problems. So first problem is, let T from B to W be a linear transformation. Then we have to prove this and this. That is, kernel T is a subspace of this V and range T is a subspace of W. So here both V and W is vector space, and kernel T, you know that T, that V from V such that T of V equal to 0. So this is T, and range T is the set of all TV such that V belongs to V. Okay? So this is the definition of Cartesian range. So first we will prove this first one. So how to solve subspace? So any set, so you have to prove Cartesian is a subspace. So to prove subspace, we have to take two elements from this Cartesian and two constant from the field on which these vector spaces are defined, and then we have to prove AU plus BV also belongs to this Cartesian. So this is our aim. We prove this is taking this, we have to prove this. Okay? To prove subspace. So first of all, we take UV from RT and AB from field. So as U and V belongs to RT, so from definition of RT, we say TU equal to 0 and TV equal to 0. Okay? So therefore, AU plus BV, if we find T of this, therefore, as T is linear, so we can write this as T is linear. So we have to write reason here as T is linear. Therefore, as this is 0, so A into 0 plus B as this is 0, so therefore 0. So T of this equal to 0. From this we can conclude AU plus BV belongs to Cartesian. Okay? So you take UV from Cartesian and AB from A, and you have shown that AU plus BV equal to BV belongs to Cartesian. So from this we can conclude Cartesian is a subspace of V, as this is a subset of V. Okay, so it will make subspace of this vector space. So now we will prove the second problem. So the definition of range is this. We will use this. So to show the range T is subspace, we have to take two elements U dash from this range T and AB from the field. Okay, so as U and U dash belongs to range T, so there exist V and V dash in V such that this T of V equal to U and T of V dash equal to U dash. Okay? So we take U dash from range T. So range T is a subset of W. So all TU belongs to W. So therefore, if we take U dash from range T, then there exists V and V dash in V such that T will assign V and V dash to U and U dash in W. So therefore, we can write this. Okay? Now we have to show AU plus BU dash belongs to range T. Okay, we have to show this. So for that, take this and you can write A, you use this, you can write TB in place of U and TB dash in place of U dash. So therefore, this can be written as T of AB plus BB dash as T is linear. Okay? So you know V is a vector space, so therefore as V and V dash belongs to V, so therefore AB plus BV dash belongs to V, and this implies T of AB plus BV dash belongs to range T. So therefore this way, so this belongs to range T, that is AU plus bu dash belongs to range T. So you take u dash belongs to range T and you prove au plus bu dash belongs to range T. So therefore you can conclude this range T is a subspace of the vector space W. Okay, that's it. Now the second problem is, let T be a on one linear transformation. S is given a linearly independent set in V. You have to show this set, that is Tv1, Tv2 dot dot Tvk is a linearly independent set in W. You have to show that. So to show the linear independence of this set, you have to take A1, A2 dot dot AK in the field on which these vector spaces are defined. So therefore A1 Tv1 plus A2 Tv2 plus dot 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 AK Tvk equal to 0. Let us take. Okay? So to prove the linearly independence of this set, we have to show this all ai equal to 0 for all I equal to 1 to k. Okay, we have to show that by using the property that T is a linear and 1 1. So we will show that. So from this, you can write T of a1 v1 plus T of a2 v2 plus dot dot plus T of ak vk equal to 0. Why? As T is linear. Okay? So therefore from this you can write a1 v1 plus a2 v2 plus dot dot ak vk equal to 0. This is also T is linear. Okay? Now as T is 1 1, as T is 1 1, so T assign these elements to 0. So therefore this belongs to car T. And we have one theorem that if the transformation, linear transformation is 1 1, then car T will be 0, contains only 0 element. So therefore, so 0 will go to 0 as T is 1 1. So therefore from this we can write this element must be 0. A1 V1 plus A2 V2 plus dot 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 plus AK VK equal to 0 as T is 1 1. Okay. So now it is given that U V1 V2 dot dot VK is linearly independent. So as V1 V2 VK are linearly independent, this will imply that A1 equal to 0, A2 equal to 0 plus dot dot AK equal to 0. Why? As S is linearly independent. Okay. So the reason you have to write why this y is written. Okay. So first we assume that this y equal to 0 and ultimately this imply all ai are 0. So from this we can conclude that this set is linearly independent in W. Okay, as these all vectors are from W. Okay, so therefore this set will be linearly independent in W. And these P1, P2 or all are belongs to B. So this is linearly independent in B. So that's it. If you like it, please subscribe my channel and share with your friends. It will help you. So thank you very much.